Welcome back to the classroom. My name is Mr. Wong. Today we'll be covering the Module 7 Inquiry Question 4, which is about Einstein's contribution with special relativity. This is going to be the 2019 HSC Physics paper, question 27. As you can see, it's worth 6 marks. For the very first question, we need to outline a thought experiment that relates to the prediction of time dilation. Okay, so here goes explaining this first concept. I'll try and draw a diagram to sort of picture it. Imagine a person on a train. This is the exact same sample that Einstein used. Imagine a person is standing inside that train. Imagine this train is moving in this particular direction at the speed of light. Imagine another person standing outside. We'll call this person inside this train as reference 1 to explain that they have one reference frame. We'll say the person standing outside, who is stationary, as reference 2. Now this example works in both cases because the frame of reference is inertial. As in reference 1 here, they are traveling at a constant velocity, and reference 2 is also traveling at a constant velocity, a velocity of 0. Now say for example, at some point in time, there comes a lightning strike. And it strikes our train like this. The question is, how do these two individuals see the strike different to each other? And the thing is, reference 2 will see both light bulbs coming or striking the train at the same rate. So they come to this person at the same time. However, for our other observer, and I'll do it in a different color just to make it really clear. However, for this observer here, the light from this bulb, so strike arrives earlier, and then this one here, this lightning strike arrives later. But the question is, they both struck the train at the same time. So why is this one coming earlier than this one? Einstein explained that's to do with the fact that light travels at a constant velocity in a vacuum. So to make up, so it takes a particular distance for light to travel, given the fact that it travels at a constant speed. So now that the train is actually moving closer towards the first lightning bulb here, it takes less distance for the bulb to travel towards this person. And so they'll see it earlier. While as this lightning bulb, once it hits this train, it still needs time for it to travel to this person as they are traveling at the speed of light away from the lightning bulb here. So this is what we mean by time dilation, or this is the first theorized event of time dilation. It's the idea that the speed of light is constant, and so distance and time are relative quantities to the speed of light, given that we know speed of light is constant value, and the formula for velocity, I'll write it over here, the velocity is d over t. Now if this is constant, that means the ratio of these two would vary. Okay, because if this is the same, this can't be the same, and this can't, or this can't be absolute, this can't be absolute. They need to switch around to match this one here. Okay, so let's write something down for this and we can move on from there. Okay, so that concludes our response. We'll just do a quick summary here. So the thing we see here with the first person is when the train is moving at the speed of light, when the two lightning bolts strike, they will see the bolt on this side of the train first, and then they'll see the bolt on this one second. The reason being is that they're seeing it takes a smaller distance for light to travel to this person here than it is from this here. So the fact that they're experiencing two lightning strikes that occurred at the same time but arrive in their viewpoint at different times afterwards is a demonstration of time dilation. And so this is the thought experiment we can use to represent the existence of time dilation. Okay, so we'll move on from there. We want to outline evidence that validated the prediction of time dilation. The famous experiment is the atomic clocks. So say the experiment we're looking at is the atomic clocks. So let's quickly summarize what happened. I might just quickly draw this out as well in case people forgot. So the idea is we have the Earth and it's rotating in a specific direction. Let's say in this direction here. Let's say the plane traveled in this direction here, and also the plane traveled in this direction here. Okay, so from their findings, we find that for the plane that's traveling in the same direction of rotation of the planet, they found that the plane that was traveling in the direction opposing the movement of the planet had a greater time dilation. So had a greater time dilation than the planet that was traveling in the same direction as the planet that in the same direction that the planet was rotating. So regardless, we still have time dilation, and might I add that it was comparing an atomic clock on Earth with the atomic clocks on the two planes. So I just want to make that very clear. The reason why this plane here, the one that opposes the rotation of the Earth, has a greater time dilation is because, relatively speaking, the position of the clock and this plane here, there's a greater difference in their velocity, in their relative velocity, in comparison to the plane that's rotating in the same direction. So that's what happens there. I'll get rid of this and I'll write a proper response for it now. Okay, so that concludes our outline of the experimental evidence that demonstrates time dilation. You could have mentioned the half-life of muons and the detection of those as well, but the atomic clocks and the plane is a good starting point. So just to summarize, two planes flew in opposite directions around the Earth, and their times were compared with the atomic clocks on Earth. What they found was the two atomic clocks on the planes had a very small time dilation when compared with the atomic clock on Earth, and specifically speaking, the plane that traveled in the opposing direction of the Earth's rotation experienced a larger time dilation. Hopefully you found this useful in explaining Einstein's contribution and his understanding of special relativity. Give this video a like if you found it useful, and I'll see you next time.